What's up everyone, it's Powell, and buckle up because if you enjoyed completing the square, you're going to like this video because this video covers going from the general form of conic sections to the standard form of conic sections, which involves double completing the square. This is fun. Now if you haven't watched my other completing the square videos, I'll leave links to them in the description. It does help because I have a specific way of doing this, so I'm just going to go on the assumption that you have watched at least one of those videos. So the reason we do this in the first place is because conic sections are given in two forms. The general form, which you see on the left here, which is just this long polynomial, this long string of terms of x squared, x, xy, etc. And then the standard form, which is also sometimes called HK form, which is the form you graph from. It's easy to identify a conic section from its general form, but it's not easy to graph it, and that's why we have to change it to its standard form to graph. So the first example is the general form of a circle into the standard form of a circle, and I covered graphing standard form equations, circles in standard form. I'll leave that in the description as well. So the equation we're going to start with is x squared minus 8x plus y squared plus 2y plus 13 equals 0. Again, we have this long polynomial that we have to switch into what you see on the right side. So I'm going to do the first two steps in one, and that is I'm going to get the constant of 13 over to the right side, and I'm also going to leave a space after each of the linear terms, so a space after the negative 8x and a space after the 2y. Again, I'm going to do this all in one step. So x squared minus 8x, leave a space, plus y squared plus 2y, leave a space, and the 13 moves to the right side as negative 13. Now, in completing the square, we take the linear coefficient, cut it in half, and square it, and add it, because the whole idea of completing the square is to make this x squared minus 8x into a trinomial, which is a perfect square, and we're going to do the same thing with the y's. So half of negative 8 is negative 4, and negative 4 squared is 16. But in order to keep this balanced, I have to add 16 to the left and to the right. So we add 16 to the right. I'm going to do the same thing to the y's. Half of 2 is 1. 1 squared is also 1. And add 1 to the right. So now we have this trinomial, which we now completed it as a square, and this trinomial, which we completed as a square. Because x squared minus 8x plus 16 is equal to x minus 4 squared. It's always x plus half the linear coefficient. So x minus 4 squared. And y squared plus 2y plus 1 becomes y plus 1 squared. And then we combine all the terms on the right side. Negative 13 plus 16 plus 1 is 4. And if we take a step back, we can see that this matches this form, where we have the center and the radius all for us. So that shows how we can go from the general form of a circle into the standard form of a circle. It's pretty cool. But it gets a little complicated when we start talking about some of the other conic sections. Parabolas I, again, already covered, but hyperbolas and ellipses can be a little weird. So I'm going to show you an example of doing this same process to the general form of an ellipse. Now you might also notice that, just to give a quick look at general forms, is that the general forms of all conic sections are pretty much the same. And it all depends on what A, B, C, D, E, and F are. So the general form of an ellipse is this long string of polynomials. But the standard form looks like this. It's a little different from our circle form. A little different in that we have denominators on the left. But you'll see how we get those denominators as we go. This is exciting. So, again, the first thing I'm going to do is write this the way it should be written. There we go. My first step was done for me. So again, what I'm going to do is leave a space after the linear terms and get that negative 36 over, or that positive 36 over to the right. So we have 16x squared plus 96x, leave a space, plus 9y squared minus 36y, leave a space, equals that negative 36 constant that we got over to the right side. Now the second step with this is that we have coefficients for the x squared and y squared terms. We have to factor those out. So I'm going to factor out 16, and we get x squared plus 6x. The space is still there. Plus 9 parentheses y squared minus 4. 4y. Space is still there. And nothing happens to the negative 36 at the moment. And here's where it gets a little weird because, again, we take half of the linear term and square it to get what we have to complete the square. So half of 6 is 3, 3 squared is 9. But I don't add a 9 to the right side because this is a 9 times 16. So I have to add a 9 times 16 to the right side, or 144. Same thing with this. I have negative 4 cut in half is negative 2. Negative 2 squared is 4, so I add a 4. But to the right side, I add a 4 times 9, or 36. And then we have two trinomials that are now perfect squares. So this ends up being 16 times x plus the linear term in half squared, so x plus 3 squared, plus 9 times y minus 2 squared equals negative 36 plus 36. Those are 0, so we just have 144 left. And I'm going to move this just so the equal signs are in a row. There we go. Now the last step to make the general form look like the standard form is that we need to have a 1 on the right and denominators on the left. And the only way to do that is to divide everybody by 144, because that will ensure that we have a 1 on the right side. So that equals 1 on the right. And if we look at the first term on the left, we have a 16 in the numerator, we have a 144 in the denominator. 16 goes into 144 9 times. So we have x plus 3 squared over 144 divided by 16, which is 9. And then we have y minus 2 squared over 144 divided by 9, which is 16. And as you can see, we have the general form changed into what the standard form of an ellipse should be. And if you know how to graph an ellipse, we have the center and we have the semi and major axes that we can graph. So that's pretty cool. And a hyperbola is very similar to this, but you have negatives floating around. So I may get to an example like that later, especially when I talk about graphing hyperbolas. So if you like this video, please subscribe and comment below on any topics you'd like me to cover. And I will have a couple more videos with completing the square because I think it's a very important skill. So we're going to look a little deeper into completing the square. So thanks for watching.